Hello, this is Peter Yurkett, and this is, for now, the last video lecture dealing with text mining, and is in some sense the ultimate goal of text mining, short of natural language processing. Previously, we looked at both clustering and classification in terms of the entire data set, including numerical and categorical variables. And in SAS, that means generally leaving out the text variables. But the whole idea behind text mining is to concentrate on the text variables. So we have other topics that do this, and they've been generally given the name TextTopics, although there is a text cluster and a text profile nodes in SAS. The idea is that a topic is a combination of terms, tokens that describe something a little more than just the words themselves, a concept, a theme, an idea. And generally what happens is you put a whole bunch of words together that appear frequently near each other or with high frequencies, and text mining is just counting words anyway. And so you kind of put them together with these main ideas in text mining: multi-word counts, co-references, synonyms, things that multiple words that appear more frequently than they should by chance alone. Clustering, again, is using the text to find documents that are near each other, as we talked about in the clustering session. And you use the usual distance measurements like TF, IDF, and Euclidean distance and cosine distance. And then classification is, as usual, you attempt to see what words or combination of words lead to either a yes serious value or a no serious value, or in sentiment analysis a favorable review or an unfavorable review or a neutral review. So that the basic ideas that we got out of preparing text for mining, clustering, and classifications are now extended into combinations of words rather than all the variables in a particular data set. The open classes of words, nouns, adjectives, adverbs, and verbs, tend to be the ones that are used most often in topic lists. And one of the sort of advantages, if you wish to think that way, is that topics can bleed over across clusters, and some aspects of topics that might lead to a no value for serious could bleed over into the group of words that classify a yes value. So unless you're using fuzzy sets or probabilities, topic combinations, clustering, and so on, don't necessarily get assigned to a particular cluster. A document does not necessarily get assigned to a particular cluster. You can do this by just counting, but SAS has grouped these counts into something called a text topic node. Python and the other languages have specialized techniques that I'll get to probably in the next slide. You can do it unsupervised, i.e. clustering, supervised, classification, or a combination of both. Generally, even if the fancier techniques in Python and so on and R are used, since the number of terms that can possibly be used to be included in a topic can actually be all the words in the Oxford Dictionary of English, a couple of 600,000 of them. Generally, you use fewer, but very often you get well into the thousands, if not tens and hundreds of thousands. And all technique, and SAS in particular, and other techniques use singular value decomposition to reduce the number of columns, which then automatically get clumped into smaller groups than the entire Oxford Dictionary of English. So that's the overall approach. Nowadays, the topic has gotten very mathematical and has become somewhat controversial, if you want to talk about it that way. But let me be a little more precise. A topic, by definition in this approach, is a distribution over a fixed vocabulary. And what we mean by that is, if you put all the words over from some vocabulary, for instance, using WordNet, we could take a word, all its synonyms, and all the tree, or all the ontology tree that has, for instance, a car and a truck in a group of wheeled vehicles. So then we would add to car and truck, which could be a synset, not really a synset, but could be two. We add vehicles, we add motor vehicles, and then we look at all the subsets of motor vehicles. So in some sense, we're extending the synonyms of a particular word to all the other onyms, not all the others, but some of the other onyms. And I call that an extended synset. It's really a part of the ontology tree in WordNet or other vocabulary rankings like networks. So what you do is you put all the words in a row, on the x-axis, for instance, as a category, and on the y-axis you say how likely is that word going to be in this topic. So a topic is a statistical distribution over a fixed vocabulary. Once given that, we use either supervised or unsupervised techniques to then compare the actual probability of words in a document or in a corpus to these probability distributions over a fixed vocabulary, to these topic distributions. And that is these days done with a lot of people use something called latent Dirichlet modeling. Now the words are fancy and the ideas are even fancier. The notion is that we have a couple of statistical distributions, a Dirichlet distribution, which is generated by a bunch of gamma distributions. And if you're not into probability and statistical probability, I don't think it's going to bother you much. But those of you that want to learn about this topic, I have given you a reference to a PDF file that you can download from the internet. Just search on that. And then each of Python, R, and Java have also versions of latent Dirichlet modeling. So you've got the links here if you want to go chase them down. In effect, what happens is you see how likely it is that one of these distributions over the fixed vocabulary would generate the text that you're studying. And what you do is you use probability maximization, expectation maximization techniques to find the probabilities that a particular fixed vocabulary generates the words in the documents you're studying, and you pick the particular vocabulary that is most likely going to generate the document you're studying, using some of these statistical distributions to actually do the calculations. Like I say, it's pretty mathematical and statistical, but it's widely used. Now, sometime before LDA became both known and popular, SAS people actually studied the question of. I mean, when LDA first appeared, the SAS people studied to what extent LDA can be applied to studying topics in text, and to a technique that they call rotated singular value decomposition, which I talked about in the previous slide, and found that actually their particular version of rotated singular value decomposition was both faster and possibly a little better. So SAS does not use the text mining module in Enterprise Miner does not necessarily use directly modeling, but SAS has a contextual module, SAS context module, whatever it's called, which costs extra, and like sentiment analysis, which is another module that SAS sells in addition to text mining. So the text mining procedures we use in this class are actually a subset of what they call rotated SVD, and they'll give you topics. So this is kind of I don't know that we call this a controversy. People that use LDA don't really care what the heck SAS does, and I suspect in some sense SAS really doesn't care what people that use these programs do. But they both generate topics, and the results are not that exact and precise that we can actually say with any kind of great confidence that these topics are closer to this document than these topics. So the whole thing is really an approximation, and pretty much leads a user to think about the various topics that are brought up by the software, and then to actually decide whether they want to use those topics or not. So with this kind of a hedging, cover your behind kind of approach to topic modeling, I'm going to show you what SAS actually produces, and then for those people that are not using SAS, go find the procedures in language you are using that look a little bit like these results. So SAS has a text cluster node, which is not the same as the cluster node. The cluster nodes you get out of Enterprise Miner, the text cluster node you get out of Text Miner. And it's similar to unsupervised structuring, except that the text cluster node in SAS uses the text variables, whereas the general clustering node out of Enterprise Miner uses all the variables except for the text variables. So in some sense, text cluster is a complement. The text cluster node is a complement to the cluster node in Enterprise Miner. Text cluster node is in Text Miner. And here's what it gives you. It shows you for every, using this particular table that you get out of the output, the exported tables, you get an observation, 1 through whatever, 7,000, and the text, this is the text that's being analyzed, and you get a cluster number. Now in this case I picked a table that had 20-some clusters, which is what I got. You can probably decide how many you want. And then you identify that, and then you get some kind of scores. Now actually it gives you the rest of the variables. So what you get out of the text cluster node is a bunch of text, the cluster to which it belongs, and what you do is you then download this table, including the text and the cluster number, and then you segment, you break this table up into all the clusters, into all the observations that have cluster 17, as opposed to 15, as opposed to 20, and then you go ahead and do text mining on those clusters. So and that should give you for each cluster a set of words that give you that from your viewpoint, human being viewpoint, you might put together and form a topic. So that's a basic node in SAS. So what you're doing, and in effect what's happening is you're taking the term frequency, inverse document frequency of the text variables and generating clusters based on just those values, like I showed you in the clustering session a couple of weeks ago. So that's one output of the SAS topic nodes. Another one is the topics a little more literally. So what we have here now is a user ID, the term ID, a topic ID, 25 topics, a document cutoff value. Now this is a measurement of how much a document has to have these combinations of words after applying the singular value decomposition, and a term value, and the higher these are, the most important they are. So what we have here is a bunch of words that SAS thinks is a topic. Now they're not always great, but for instance, here's a set: seizure, febrile seizure, eye, emergency room. This appears to be a reaction to vaccination based on some kind of seizures, where the body vibrates and the person, can't talk well, a little bit like an epileptic fit, but hopefully it's not that bad. And then there's a topic here that talks about chicken pox, registered, nurse registered. So apparently what happened is, for a bunch of these events, the nurse that first registered the patient into the clinic, where they were having went to having trouble, and the nurse apparently made an initial determination that this is a chickenpox type thing, and then there's a bunch of, now this might seem kind of way out, but considering that the strengths of the combination is pretty strong. I mean, here we got 0.26, here's still 0.26 in terms of the terms, and the document frequency goes to maybe 3/4 or 3/5 of what the most frequent one is. So we can't really take this topic and dismiss it. It's too strong in the report. Actually, it turns out that the term frequencies of these topics are pretty much the same, so it would in effect be the document cutoff that would determine where you go. And these are in terms of term cutoff, and these are not quite in order, but high ones tend to be first. So you get the number of terms and the number of documents involved. And considering we've got 7,000 rows in this, 274 of them with that restriction of words is a strong indication that this combination may mean something. Now it's up to you, the user, to understand what this combination might mean and possibly give it a name. Whoop, come back. And possibly give it a name. Come on. Yeah. Well, no, I guess we did go to the next. And possibly give that a shorter name. So the work you have to do in clustering, you also have to do for TextTopics, because obviously the computer doesn't understand this combination of words, but you do. So one of the things you should do with both clustering and topics is to give that topic a name. Not all of these topics are going to be meaningful to you, but some of them might give you some insights that you may not have had without them. So that's the text topic node. Then there is a text profile, and now the text topics and the clustering nodes do not use the target variable, serious. They don't prejudge whether this is a serious case or not. They're looking at all the other variables or all the other terms to see whether how they fit in together a bunch of clusters. The target variable is used in the text profile node in SAS. And what it shows you is for each value of the series variable, no and yes, and here they are again, it is these terms that seem most associated with series equals no, and these terms that are most associated with series equals yes. And then the terms come, I didn't explode this file, but this is one of the output files that you get from the text profile node. By the way, if you use hierarchical clustering, and you then get a tree for clustering and a tree for predicting. And so this gives you, for each target variable value, those terms that most closely lead to that. And Weiss describes this, I think, in chapter 3 or 4, in how terms associate with each other. So that's an output that might give you a clue as to what combination. So here's 8 terms that, in some sense, together seem to indicate that this is not a serious observation. And here's a set of terms that might. Now, secretion and I don't know what all, hospitalization, obviously, pain, so on. So again, you might need to combine those terms in your mind and give them a name. And then the final text mining node that SAS uses in text miner is a text rule builder, text rules. And here what I've done is I've taken the middle of the table, because the table began with all serials equals no, and then switched to serials equals yes. And these are the words that in a rule that will lead to no. So no adverse effects, well, obviously that leads to no. Non-serial, let's see, no adverse symptoms, pregnancy report will lead to no, cysts may, but I think the yes would be more arm and office, fever and cause would obviously lead to yes, ultrasound. So what you have is, in this case, you have 25 rules, and here, and this one, like the classification node, gives you the results about how successful SAS was in predicting the no and yes based on training data and validation data. And you get some of the scores. For instance, here's your F1 score. Now, an F1 score of 14 ain't all that great, but an F1 score of 47 is not bad at all. And we're getting into 57s and 56s, and here's a 67. So these are fairly strong rules. Valid perception here. Recall, you get a recall score, you get a tool evaluation, probably a few more columns I haven't shown you. So these 3 results, this one, text rule builder, text profile, and text topics, would be the 3 nodes in text miner that you would use, short of using LDA and fancier programs, to see what the topics are that various observations fall into, and allow you to predict yes and no. And this is really text mining, because the only inputs to these 3 nodes are the text variables and the target variables. So those of you that are using other software like Python and R, take a look at these tables produced by SAS and see if you can find procedures that mimic this output. Gives you sort of the same output. And you might have to do a little reading. I've given you the links to the C language uses of latent Dirichlet modeling or analysis, and then see if you can produce output that are similar to that. So I'm going to quit here, and this for now will be the last video that I'm going to produce before the class starts. If you want more videos, tell me the topics and I'll try to reproduce them. In any case, questions are welcome. Thank you very much.